Welcome to Homework Lib.
First, let's determine the degrees of freedom at mean square and F value. The degrees of freedom between would be equal to k minus 1, which would be 3 minus 1, or 2. The degrees of freedom within would be n minus k, which would be 21 minus 3, or 18. The total degrees of freedom would be n minus 1, which is 21 minus 1, or 20. The mean square between would be the SS between over the DF, degrees of freedom between, which would be 147.32 divided by 2, or 73.66. And the mean square within would be the SS within, which is 862.99 over 18, the degrees of freedom within, and that's about 47.94. So to complete the ANOVA table, you got your between, within, total, got your degrees of freedom, and you got your mean square. And F would be the mean square between over the mean square within. So that's 73.66 over 47.94, and that's 1.54. To draw a conclusion about F that's been obtained, we compare it to the critical value of F for an alpha of 0.05 with 2 degrees of freedom within and 2 degrees of freedom between and 18 degrees of freedom within. So using an F distribution table or calculator, we'd find that the critical F value is about 3.55. And since our obtained 1.54 or less is less than that, we do not reject the null hypothesis, which suggests there are no significant differences between the group means. For C, I think filling in the table is the right format. Since the ANOVA did not show significant differences, post hoc tests are not necessary. They're only conducted when the ANOVA shows a significant difference, indicating a need to determine which specific groups differ from each other. One common measure of effect size for ANOVA is eta squared, and that's the SS between over the SS total, and so that's 147.32 over 1010.31, that's about 0.146. And that indicates that about 14.6% of the total variability in the dependent variable is accounted for by the independent variable. This is considered a small to moderate effect size, suggesting that the independent variable has a modest influence on the dependent variable.